Okay, let's move on to our next section, which is 10.2, central angles and arcs. And if you notice, we still have circles here. Now we're looking at something that looks a bit like a piece of a pizza or a piece of a pie. And so we're going to be talking about that type of information today. And first thing we want to remember is how many degrees there are in a circle. Okay, we've talked about that. There are 360 degrees in a circle. Okay, and basically, if you divide those 360 degrees up into angles, different sized angles, those are called central angles. And a central angle is going to be, let's get a better color than that, a central angle is going to be an angle with its vertex or its corner at the center of the circle. Okay, so the center of the circle is going to be the corner of that angle, and a central angle is like a piece of the pie. So the angle measure is going to be basically how many degrees the tip of that piece of pie is, basically. And since it's an angle, it will be measured in degrees. Okay, so then if we have a central angle, we also will have what's called an arc. Okay, so the arc is a part of a circle created by the endpoints on the circle, created by the endpoints on the circle. Okay, and an arc is like the outside, the crust of the pie. So in the diagram, what is the name of the central angle? So if we look back up here at our diagram, our central angle is an angle, and it takes 3 points to name an angle. So we are going to call it angle. Remember that vertex always has to be in the middle. A, O, B, or BOA would also be appropriate. So it'd be angle, excuse me. It also takes 3 points to name an angle. So if we're looking at our diagram up here, this right here that I have highlighted in red, I can erase that for a second, that is the arc. This right here, the top of the pizza, the crust there, or the top of the pizza, is going to be the central angle. Okay, and there's going to be some things that we're going to learn about central angles and arcs and their relationship. Okay, first of all, we need to realize that there are different types of arcs. Remember that arcs are like the crust of the pie. So when naming them, we stay on the outside. So it's like running around the outside of the track kind of a thing. We do not cut through the center of the track or the center of the pizza. We are not a pizza cutter going through the middle. We are staying on the outside. So we have 3 types of arcs. First one we're going to talk about is a minor arc. Second one will be a major arc. And then on the next page, we're going to talk about a diameter. Okay. A minor arc, well, minor means small, so it is less than 180 degrees. Okay, minor arcs are named using the 2 endpoints on the circle. This is the short route. So if we're talking about a minor arc, we're taking the short route from point A to point B. Okay, so on this picture we have here, the short route from point A to point B goes from here to here. That's a minor arc. Okay, what is the name of the minor arc in the circle? Well, it's an arc, so just like we kind of did before, we're going to put the word, and it's going to be arc AB. Sometimes if you see it in a textbook or something like that, it might be an arc with a little arc over the top of it, an arc hat, if you will, like we like to call them. A major arc is, major means big. A major arc is greater than 180 degrees. Major arcs are named using the 2 endpoints and a point in between. So it takes, and it's the longer route from point A to point B. Okay, so instead of taking the short route up here from point A to point B, I'm going to go the long way. So I'm going to go from here, and I'm going to go all the way around through M, all the way over to B. So that's going to be a major arc, and it takes 3 points to name that arc. Since it's major, it's going to take 3 points to name it. Okay, so the name of the major arc up there in the circle is arc. okay, because that's what it is. And we are going from A to B, but we are going through M. So it's going to be A, M, B. Okay, so on this slide, we talked about minor, less than 180, major, greater than 180. On the next slide, we're going to talk about what is exactly 180. So when it is exactly 180 degrees, it's called a semicircle. Semi means half, okay? So semicircle is the arc created by the, well, if we think back to our vocabulary, this goes from one side to the other through the center. So it is made by a diameter, and it basically cuts the circle in half. So if a whole circle is 360 degrees, a semicircle is exactly 180 degrees. A semicircle is considered a major arc, so we name it with 3 points, just like we did the major arc on the other page. And remember, we stay on the outside of the crust of the pie when we are naming it. So if we are going from A to B, we stay on the outside, and in this case, it's a major arc, so we are going to go through point C. So it's going to be arc A. The point we go through is C, and we end at B. Excuse me. So then how do we measure arcs? Well, it's very simple, okay? The measure of the central angle and the measure of the arc are equal to each other. Okay, and we'll talk about some examples of that here in just a second, which basically means central angle, arc are equal to each other. The inside of the piece of the pie equals the crust of the piece of the pie. And just like segments and angles, we can add the measures of arcs together. Okay, so let's just take a quick look. Before I answer any of these questions down here, I want to label all of the degrees and everything that I know about this picture so far. Okay, so that will make answering those questions on the bottom very simple. So I know that TR is a diameter. So that means this cuts my circle in half, which means this top part is going to be 180 degrees, which means the bottom half is also going to be 180 degrees. And if I already know that this is 110, then I know that this has to be 70 degrees. Okay, so then I just answer the questions. I have everything labeled in my diagram that I need. So if I want to know the measure of arc RS, I'm going from R to S. It's only 2 letters, so I know I'm taking the short route. R to S is going to be 110 degrees because the measure of that central angle and the arc are the same. The measure of RST, now I'm going from R through S over to T, and I'm going to stop right there, which means I just went halfway around the circle, which means RST is 180 degrees. The measure of arc TS, that's just this little guy from here to here. TS, we have it labeled already. I can just look at my diagram. That's 70 degrees. And the measure of arc STR, so maybe I need to erase a couple of these lines that I have in here that are a little bit confusing, making it very, I'm going to put my 70 degrees back in there. Okay, and I'm going STR, so I'm going STR, so I'm going all the way around, and I have 2 angles in there that are included, so I'm just going to add my 2 angles together, 180 plus 70, which is 250 degrees. Okay, so here we just have a couple of more examples. Okay, so it says in here, FH is not a diameter. It kind of looks like it almost is, but we know it's not. Okay, FH is not a diameter. So we know that this guy's 40, this guy's 80, this guy's 110. I also know that all the way around my circle is exactly 360 degrees, which means I know that these guys right here, if I add those all together, 110 plus 80 plus 40, that's going to be 110 plus 120 is 230 degrees. Okay, so the label, which I know already is 230 degrees, the rest of the way has to get me to 360. So I know that it's going to be 360 minus 230, which is going to be 130 degrees. Because I know that all of these angles make a complete circle, so I know that they have to add up to be 360 degrees. Okay, so now that we have everything in our diagram all labeled, all the different pieces of it are all labeled, then we can just start looking and adding angles and arcs together if we need to. So if I want to know the measure of arc GE, that's the short route going from G to E, that's going to be that 40 degree and that 80 degree angle. We're just going to add them together. 40 plus 80 is 120 degrees. The measure of arc GEF, so let me get this out of the way here a little bit. Arc GEF is going to go from G past E over to F in that order. And I know that that's the three pieces that we have labeled already, and we calculated that out. I had it written down on there earlier as 230 degrees. That's how we calculated that rest of it as 130. And the measure of arc GF, we have labeled in there already. That GF is just from that short route from that 130 that we labeled, that we calculated out. Okay? Again, why don't you pause the video for a second, see what you can come up with, calculate the rest of these angles on this page, and then just check with what you get when you come back. Okay, so hopefully when you did these, you have it labeled the same as I do and got these same answers that I have. Okay, one last example here that you can do just on your own. Again, just making sure that you are on the right track. Let's do this one real quick together. So the only piece of information that I don't have is this big part of the circle on the, kind of what I would call on the top. So what I would do is, I know that if I add all of these guys up, 53 plus 79 plus 68, if we put that in our calculator, that is 200 degrees, which means the rest of the circle that I have left is going to be 160 degrees, because I know that that all the way around has to equal exactly 360. So now we have everything labeled, we just need to calculate what we get. JL is going to be the short route. Remember, it's 2 letters, so we are going to take the short route from J to L, which is just going to be 79 plus 53. So if we calculate 79 plus 53, we get 132 degrees. So that's JL is 132. KM, let's see, where's KM? KM is going to go, here's K, we're going over here to M. We're taking the short route, and that's just going to be the 2 angles that are labeled there, 79 and 68, which is 147 degrees. And the measure of arc JLM, let's see here, I'll do that one in yellow. JLM, again, we already calculated that one, didn't we? In order to find the 160. JLM is going to be 200 degrees. And JM, again, we already have that one calculated in there. That's this part, is going to be 160 degrees. Your homework is going to be the 10.2 class kick that you can work on once you have finished your notes.